Hi everyone, good morning. Welcome to DSCI 513, Databases and Data Retrieval. Did you have a chance to take a rest? A little bit, huh? Yeah, same here. So I'm looking forward to the New Year holidays too. Yeah, okay. All right, so in this course, let's see what we're going to cover in this course. So first of all, I'm going to go through a few announcements about the course and then get started with the first lecture's material. So the significance of this course. Because you're going to be data scientists, or maybe some of you already are, you are going to be dealing with databases a lot. Chances are, even if you're working with special types of data, that is not the kind that is usually stored in a database, you are still going to interact with databases in your jobs, at least, quite a bit during a week or a month or so. And in other situations, in industrial scale operations and data, databases are abundant. So typically, in these courses, when we learn about machine learning or statistical analysis, we have some CSV files that contains our data. But in the industry, this is usually not the case. You don't have like a CSV file that you load on your computer's memory and then start doing analysis on that. Usually, data is stored in some form of a database. And this is what we're going to be talking about in this course. Second point, what this course is and what it's not. So this course is about learning how to retrieve data from a database, mainly. So we covered the main concepts about the database, but we mainly focus on how you can retrieve the kind of data that you want from a database. And this is opposed to some more advanced database courses where you also learn how to design a database for a particular type of data. This is not that course. This is only for data scientists who are mainly interested in retrieving data efficiently and effectively from a database. Okay, so overview of the course. Let me just quickly show you what we have here. So again, 8 lectures here. For the most part, in 6 lectures, we're going to be covering stuff about data that looks like a table, and we call that the relational databases. And for the last 2 courses, for the last 2 lectures, we're going to be also talking about some kind of unstructured or semi-structured databases. So that will be the kind of outline of the course. But right now, these topics may not mean that much to you. They look a lot like some kind of wrangling data techniques, but we'll get into more details about that. Okay. All right. Okay, so the main things we're going to be talking about in this lecture is why do we need to use databases? So this hanging questions, why should we not just stick to CSV files and text files, and why are we making our lives harder? So we're going to be covering that question. We'll also talk about the relational model data that looks like a table, how we store that. And then we're going to talk a bit about SQL. Maybe you've heard this term before. It's the name of a kind of a language that you use to query data. And then I will introduce to you some basic SQL queries by the end of this lecture. And that will be what we'll be discussing today. Okay. So let's start with a question here. Okay, so can you tell me why do we not always use spreadsheets over like storing data in a pandas data frame? A couple of reasons, yes? Right, we're kind of limited by what we visually see, and kind of exploring the data in that manner will become harder and harder as the size of the data grows. Other reasons? Yes? There's a limit to how much data we can put in an Excel file. That's right. Especially when you start loading like heavy data, your computer just starts freezing when you scroll through that data, and when you try to do some kind of operations on that data, then yeah, it's not really that effective. Again, some problem about when you kind of trying to scale things up. Any other reasons? Yes?
It's reproducible, so you can repeat what you're doing with multiple sets of data at the same time.
Exactly. That's perhaps one of the most important reasons that we use pandas data frames over spreadsheets for data wrangling, and that's because what we want to make what we're doing reproducible. So in an Excel file, for example, you load some data, you start working on that data, and then processing it, and then if I give you a new version of that data, you have to kind of repeat the whole thing. And that's kind of not reproducible because you have to point and click and do some manual editing of stuff. So yes, you can use something called macros in Excel, but it's still not like a script that you can read through or you can version control. Okay. Any other reasons? Yes?
Once we are using pandas data frames, we are using codes to access that, and it's going to be much faster than browsing Excel files.
Yeah, sure, exactly. Yeah. So when we're using code, it's like using terminal over the GUI of Windows or Mac. So there's a learning curve, but things become much faster when you get used to the kind of the coding behind something like like Pandas or R. So yeah, there's again an element of speed there. That's good. Yeah.
I'm not sure if Excel has some mechanism to index it when we actually input the data.
For retrieving data effectively. Yeah, I don't know either, but yeah, that's a good point as well. So when we don't have a kind of a mechanism for indexing, then retrieving data at scale, again, would be slower. Okay, that was good. Yeah, so this is, again, kind of the things that you pointed out. All right, now here's the question. So now, okay, we have this pandas data frame thing that we're very happy about. Now, what are some kind of problems with a pandas data frame or storing data in a CSV file and then loading it as a pandas data frame? Yes?
We need those space capacity in our computer to be able to load data frames we may not have to be in.
Yeah, so the data set size might be just very large, like you have 1 terabytes of data, and then if you have it as a data frame, it'll be either impossible to load, or if you're gonna, have some fancy techniques, then it will still be very, very tricky to handle. What else? Okay, let me, yeah.
Is it related to about let's say large database, we can't load them at once. So with pandas data frame, we need to load them, let's say, by maximum number of rows to avoid memory overflow or anything like that.
That's true, yes. The thing is, with pandas, by default, we typically load everything onto the memory, and then we start processing that from the memory. It is possible to load big files in chunks and process them in chunks, but we'll discuss why this is also leads to problems further down the road. And yeah, we're going to cover that. Yes?
Would it be so far less convenient to share pandas data frame? You have exported to CSV and somebody else?
Yes. This kind of relates to the main points of why we need to use a database. So because sharing the data that we have, it kind of becomes tricky. So before that, let me give you the example of a situation where people use a database over like CSV files or text file for storing data. Consider like UBC as a university, and we want to store information about employees, about students, about staff. So when you think in that terms, is it really doable to store everything inside of text files? What would be the kind of problems that we run into pretty quickly if we do that? Apart from the fact that this will be a very large data set, apart from that. So people are working in different departments. Okay, you have you have put the data on some kind of server somewhere, and people start downloading that and working on that. Yes?
If one person makes an update to the CSV, then they have to push it onto the internet for other people to
Exactly. Yeah. So one of the problems is that, okay, you want to make a change to that data set. You want to update the information about the student. Okay, you do that, but before that you have to kind of, I don't know, call everybody in UBC, say, hey, hold on, I'm going to update the information about this particular student, and then you can kind of go on and do your thing after that. So we really don't want to do that, and that's not actually even practical, right? What is one other reason? Yes?
Security, one of the aspects that you may not want one department to know the entire university's like salary, for example.
Precisely. Exactly, yeah. Yes, definitely. Yeah. That's again one of the other most important reasons, the problem of security. So you have this large data set, but you don't want everybody to have access to everything. And you might say, okay, I'm going to break up that data file into smaller tables, but I mean, you have to do that kind of breaking things up over and over again for each user with different access privileges and stuff like that. So just by, having this very simple example there, we're kind of realizing how important it is to have a kind of a systematic way to deal with data. Okay, just like we use something like GitHub for sharing code, for collaborating on code, we have to have a system in place in order to deal with data when it's shared among different people, and when we have concerns about various people accessing that data at the same time, and different kinds of access privileges and other things. Okay, one last reason is to prevent something like data corruption. For example, if part of your CSV file just becomes corrupt because of some problem with your hard drive, then the whole file becomes unusable. So unless you rely on the version of that file that's stored on the user's computers, if your file goes corrupt on the server, then that's it. So you have to have a backup system in place to do that. Again, you might be saying, okay, I can do that on the server. I can have a application or something that takes care of that. Sure, and that's exactly what a database management system does, that automatically for us, all in one place. Okay. All right, so here is the reasons that we kind of talked about. All right, so yeah, the answer to all of these questions, the way that we can address all of these problems is to use a database management system. We call that a DBMS for short. And that's that's a collection of programs that help us achieve the same goals that we just discussed to for example, have correct and appropriate security measures in place, to have a system for backing up the data, to kind of handling concurrent or simultaneous access to the data, to also handle large data sets in terms of efficiency and stuff like that. So there's a collection of programs that we call a database management system that takes care of all of that for us. Okay. So now, what is a database? A database is just a collection of data that is stored using a DBMS, database management system. Okay. So, yeah, this is kind of, again, things that we just talked about. A DBMS ensures that we have a system for crash recovery. We are taking care of concurrent access, data security, integrity, and we're going to be talking about these things, some of those in more detail in the next lectures. Okay, just a reminder for you, a database is the collection of the data stored in a particular way. The DBMS is the system, is the program that handles all those kinds of functionalities for us. Okay. Now let's briefly talk about a data model. So far we have seen data in the form of tables, mostly, right? But we have also seen data in the form of graphs in 512, for example. Those are just two examples, but data can be also provided to us in the form of like images or voice data or videos, stuff like that. However, the most common way that data is given to us and is represented is by using tables. Okay, so we discussed about tidy data a bit in 5.11. I think you talked more about that in 5.2.3. So if you remember, we said that each observation is represented as a row in a table, and each variable or attribute is represented as a column. So this particular way of looking at the data that we have is called a data model. Okay, so we have a model in mind that is used to represent the data that we have, because otherwise the data is just a collection of information. Okay, but with this particular data model, we say that, okay, the data model is a table. We think of the data in terms of a two-dimensional table. Okay, so just like I said, that's not the only way to represent data. That's just one way, and that's the one that we're going to be talking about for the most of this course. Okay, so for different types of data, we have different types of database management systems that handle that kind of data. So for tabular data, the ones that we are mostly used to so far in MDS, we use this kind of DBMS that's called a relational database. And we will get to why it's called relational. But for now, just have that in mind. We call it a relational. So relational is equivalent to a synonym for tabular data, basically. We can have other types of DBMSs for handling, for example, document-like data, hierarchical data for example, hierarchy of employees in a company or stuff like that. Network data, just like we've seen in 5.12, we can use graphs in order to represent network data or other more specialized kinds of data structure to store that, and so on and so forth. Okay. All right. Questions? Yes?
Might be a misconception by me, but databases not have any impact on storage. Are like database files the same size as
So, okay, do databases have an impact on storage in terms of what exactly? You mean if we use a database, then it will be more efficient to store the data? Yes, yes. Yeah, we will get to that. For example, one of the main advantages of using this particular relational model to store tables is the fact that we avoid redundancies, for example, in the database. So, yeah. Okay. Yeah, we've kind of looked at this example, social media represented using graphs. And yeah, for a document database, we might store information about each student inside of an individual document. We will not talk about databases like that, but just for you to know that something like this exists. All right. Now let's discuss the relational model. So take a look at this table and kind of start thinking about what kind of problems we may run into if we choose to store data in a table like this. Yeah, to give you a hint, it basically the most important thing relates to the question that Samson brought up. So I think we touched on this in 5.11, and there's this issue of redundancy, right? So if you choose to store everything in one big table like that, you kind of have a lot of repetitions. For example, the department for different instructors for several instructors can be the same thing, and you have to repeat that same thing over and over again. Yes? Exactly, yeah. Great point. So yeah, for example, yeah, we have this issue of redundancy. We will have a lot of repetitions. There's this issue of updating stuff. For example, if this if this data set contains, let's say, millions of rows containing the same, for example, department value, if you want to update that department value or fix something in there, then you're going to have to go through the entire several million rows in order to do that update. But instead of that, one idea would be kind of to store that department value somewhere else and kind of link to that value so that you only have to just update that value at that other place and then everything automatically gets updated. Okay, so these 2 points, so you have to repeat a lot of stuff in this table. There is this issue with deleting, updating stuff, and a bunch of other things that we will also discuss that leads to this idea that, okay, maybe it's not really good to store everything in just one table, so let's break the data apart into several tables and then make some logical connections between those tables. So that is the gist, the main point of the relational model. A relational model is the way that you look at data when it's broken apart into several pieces of relations, several different tables that are related together. That is the meaning of relational data. We have multiple tables. For example, a table storing information about departments. Another table storing information about the courses that these instructors teach. And then we kind of relate them to each other so that we avoid repetition. We also ensure that we don't need to do a lot of repeated operations on the same rows, same kinds of data. And this becomes more and more obvious as we go forward in the course. It might not make that much sense to you at this point, but we will see examples of how this makes things more efficient later on. Okay, so to recap, the relational model means that we have a bunch of relations, and in database terms, we call tables relations, okay? A bunch of tables that are related to each other. That's what the relational means in the relational model. Okay. All right, so in the relational model, we usually model entities with relationships. And entities in this case can, for example, in this case here, the entities are instructors, and then we might have relationships between instructors and the courses, relationship between instructors and departments, and also between courses that are offered in each department, so relations of that kind. And we also store information about entities, like the instructors, students, about courses, about departments. This is usually the way that we like to think in terms of the relational model about real-world entities and relationships. All right. Yeah, here are a bunch of examples. We can represent students in a school as entities, employees of an organization, cars of a rental company, houses in a city, and then the relations, student to a department, purchases to customers, movies to actors, customers to a bank, and so on. Okay. So yeah, we have a bunch of terminology to deal with before getting started with the more fun stuff. So, okay, tables are basically called relations in this relational model thing. This is just a formal terminology, but it's useful for you to know. Okay. The other thing is that, yeah, a bunch of terminology. Sorry that we have to go through this, but I think it's necessary to know these. So, a relation is an instance of a schema, and this is a mouthful, but it basically means that just like when we had classes and objects in Python, so class was a recipe for creating objects, and we called those objects an instance of the class. It's basically the same thing. A schema, in database terms, is a recipe for a table. So what it does is that a schema basically specifies the name of the table, like the name of the class, and also the name of and domain of each of the columns, which we call attributes. Okay. So let's take a look at an example here. This is the schema for a table. For example, we have the relation name over here, students. That's a table or a relation. And then the schema specifies what attributes or what columns we have in that particular table. So that's not a table by itself. It's a recipe for creating that table, right? So again, you can have that analogy of classes and objects in mind. The class is a recipe for creating an object. Same thing here. All right. Questions about that? Okay, one last term here. Domain is kind of what specifies the type of the data, the length of the data, the format, the range, and stuff like that about the data stored in each column. So, for example, if in this data set here I'm saying, for example, age should be an integer, in database terms, we call that the domain of that column. The domain is integer, meaning that we can only store integer values in that column. The domain of another column could be string, meaning that we can only store strings in that column. And this has a very particular significance in database terms because we are limited only to certain kinds of data to be stored in each column. And that ensures the integrity of the data set, of the database. Because if you want to insert something else into that particular column, the program, the DBMS, prevents you from that. And this is something that we really like. So we don't want people to be inserting, for example, string values for a column that should contain floats, which is used for computations. So a database, instead of letting the programmer handle that, so if it's the type of this is string, then throw an error, it handles those kinds of errors internally. So we kind of delegate those responsibilities to the DBMS rather than handling those kinds of things ourselves. Okay. All right, questions? Okay. All right, let's have a look at this graph, this diagram over here. Again, this is the schema specifying how a table should be created or populated in terms of its columns, the name of the columns, and the name of the table itself or the relation itself. We call the columns attributes in database terms. Okay, SID, name, login, age, GPA, those are attributes. Sometimes you might see that these are also called fields. And we call each row, we can call it simply a row, but in database terms, in the relational model, you'll often see these are called tuples. So each row is also called a tuple in the relational model terms. Okay, that's worth remembering. Okay. Okay, so can you name a few differences between tables in a database and tables in a spreadsheet? Yes, so one thing is that we have specific domains for the columns in a database table, but we don't have the same thing, the same constraint in a spreadsheet. What else? Yes.
Right, so each observation ID is unique for databases versus like spreadsheets that like we can records.
Yeah. So that's a good point. We will discuss this more in detail. But basically, each row should be unique at least in terms of one of the columns. So we cannot insert repetitive rows into a database. There has to be something unique about each particular row. But we will get to that later on. A good point. Anything else? Okay, so in a spreadsheet, we don't have to have names for our columns, but here you can see that we have to have names for each column in order to identify those columns. This is another difference between those. And how about database tables and pandas data frames? So again, kind of similar things. In a pandas data frame, you can have like a column that stores floats. If you insert a string into that, pandas is not going to complain. It's just going to convert the type of that whole column into the object type, for example. Yes?
Pandas has obviously, if you have something like an index, must have values, but does it have a formal index like pandas has a formal index?
Yeah, great point. Great point. Yes. So in a table inside of a database, there is no notion of order between the rows. So these are unordered sets in the most formal terms. But in pandas, we know that there is a certain order between the rows, that we can shuffle the rows, we can sort them by several different columns, but there is no notion of ordering in a database table. Okay, so we don't have something like an index that we sort by in a database table. Okay, I think we're good. Here I just summarized the properties of tables, properties of rows, and columns in a database table. Let me see if there's anything interesting to tell you. Yeah, here's the uniqueness of one of the columns. Okay, yeah, this is kind of important. So each row-column intersection, meaning that each element inside of that table can store one single value. It cannot store like a list of values. This is a very important distinction between database tables and, let's say, pandas data frames or spreadsheets. And the other thing, let me see. Yeah, there's no index-based method to retrieve rows like in pandas. And for columns, yeah, we've discussed all of that. Okay. All right. So before moving on to retrieving data from a DBMS, let's take the break here for a few minutes, and then we'll be back in maybe 4 or 5 minutes. All right, we're back. Okay, so let's see what this fuss is about, this whole SQL thing. Okay, so question here, so we discussed query languages here. What is a query? Okay, we have this database management system in place. It stores our data in the most perfect way possible. That's all great, but now we want to actually retrieve some data from that database. How can we do that? So for relational databases, there is a specialized language developed for them so that you can use that language to talk to the database. And you can use that language to retrieve data from the database or make changes to the database. And we call that a query language. And each particular type of database has its own kind of query language that might differ. Okay. Okay, now, so finally time to learn about SQL. So SQL is set, the letters SQL is set to stand for Structured Query Language. Some people say it doesn't. You can read the history of that here in this link. But basically, it's the language that we use to talk to relational database management systems in order to retrieve data or modify data stored in those systems. Okay. It's important to note that SQL is the language to talk to the DBMS. It's not the relational model. The relational model is the way that we think about data in this particular context. And it's not the database itself. The database is just a collection of the data organized in a particular way. And it's not a DBMS. The DBMS is a collection of programs that make that whole thing work. Okay. All right, so suppose that we have this table over here, and we want to retrieve the names and GPAs of students older than 25. Okay, so if you want to write a query, a SQL query, in order to retrieve that data for us, this particular data, we can write something like this. Select name, comma, age, comma, GPA from students where age is greater than 25. Looks very readable. And now let's kind of go into the detail of what that exactly means. If you run this query, you will get back something like this. And there are these two students who are older than 28, and their GPA is, so we're just retrieving the names of GPAs, and they're older than 25. Okay. All right, so this is kind of the SQL query. That's the original table that we had over here, and this is the result that we will get from that query. Yeah, I'm going to discuss all of those elements. Yeah, okay. So now let's dissect the different parts of this SQL query. So a SQL statement consists of keywords, clauses, identifiers, the terminating semicolon, and sometimes some comments. Okay, so there are all these different elements. I will go through all of them one by one. All right, so select. Let me... Okay, so the first keyword that we learn about, the most important keyword in a SQL query is select. And select is the keyword that is used to return data from particular columns. Okay, so here when we say select name, age, and GPA, we're telling the database to retrieve the column called name and the column called age and the column called GPA from that particular table to us. That's the meaning of select. So with select, we can pick particular columns to be returned to us. Okay. So the select statement is very powerful. Most of what we discuss in this course will be using select. And however, it's a very safe statement, meaning that the select statement does not change anything, it just retrieves data. That's an important distinction between select and some other SQL statements that we learn in later lectures. Okay, just know that these things that we have here, in terms of the SQL query itself, the name, the age, GPA, or the students there, these are called identifiers, and identifiers specify the name of a table or the name of a column, or something like that. Okay, so I just want to familiarize you with the terminology that we use. These are called identifiers. Okay, let's move on. All right, okay. The other keyword that we learn is from, and this is a keyword that specifies the table from which we want to retrieve data from. So we might have several tables in our database, and this specifies that, okay, I want these columns, but from this particular table here. So this table, this relation is called students, and that students has those columns, name, age, and GPA. Okay, there's another SQL keyword here in that example, which is used to place a condition on the returned values. That's called where. Okay, and after where comes a particular condition that we're interested in. Okay, so let me go back here and see if there are any questions. Yes? Yeah, okay. So good point. So it's not, I mean, there is no agreed upon style for writing SQL statements, something that everybody has to respect. But usually for readability, people tend to capitalize all of the letters in the keywords. And for other things, we write everything else in lowercase. And it is also something common to specify the names of the tables, like we capitalize the first letter of those, but that's a decision that the database manager has to make, not us. Okay. Okay, so it doesn't matter whether you capitalize things or not. SQL is just treats everything in a case-insensitive way. Yes. You can't do that. Yeah. Yeah, you can't have a column name that has the same name as a keyword. Okay, and it would be, I don't know, it doesn't really make sense to call a column select or from.
Sorry,
From maybe, yeah.
What is specific about name that is kind of highlighted?
Yeah, that's a VS Code thing, I'm not sure. Yeah. It shouldn't be highlighted. Okay. Let's move on. We can also insert comments in our SQL statement. As you can see, we have to do the double hyphens, and then we can write anything we want, and then that won't be interpreted as a SQL statement by the DBMS engine. You can also have block comments if you're interested in having those. This is not too important here. All right. One very important thing is that you have to have a semicolon at the end of your SQL statement. That's a must-have. Okay, so notice these semicolons here. And yeah, this is the note about writing the keywords in uppercase letters traditionally, but it's not a requirement. SQL is case insensitive. Okay, and okay. A bit more of terminology here. So the keywords are usually followed by some identifiers or some expressions or some other things like a condition or something like that. We call that's the combination of the keyword and what follows that up to the next keyword. We call that a clause. Okay, so when I say the select clause, I mean select plus name plus age plus GP. That's my select clause. And this is just a way of referring to the different elements of a SQL statement. Okay, so select clause or from clause. From clause would be the from keyword and the students. And in some cases, it might be more complex, but in this case, it's just that. And the where clause, which contains a condition. Okay? Again, just terminology. All right, so one last thing here is that SQL is not an imperative language, unlike something like Python or other languages that you might be used to. So in Python, we specify or we basically prescribe the exact way in which we want the commands to be executed. So we say, okay, here's a for loop. You're going to do 5 iterations. You're going to do this and that exactly. And we are the ones who have to basically think about how we want that particular operation to be done. Okay. In SQL, it's different. You declare what you want, so the goal that you have in mind, and the database engine takes care of that for you. So it's just important to know how to express what you want in a SQL, in terms of a SQL query, and the rest of the stuff is done by the database. Of interest to you might be the fact that, for example, if you have a SQL query and you try to retrieve data in an inefficient way in terms of the concepts that we've learned in 5.12, so in that case, the database management system recognizes that and optimizes that query for you. So again, you're not responsible, for the most part, for writing efficient queries. There are situations that you have to do that, but in most cases, the DBMS takes care of that for you. It's just, the only important thing for you is to be able to speak the SQL language. Everything else is going to be handled by the DBMS. All right, questions? Yes. It is always the most optimal way to achieve what you have specified in your SQL query. Yeah. You can do some things that actually make the SQL query very inefficient. That will be more advanced kind of SQL stuff, but we will talk a bit about that in one of the lectures when we call about query optimization. Okay. All right. Okay, so this whole SQL thing is a kind of a standard which is not owned by a particular company or organization, and this has become a database language standard by the American National Standards Institute, the ANSI, in 1986, and there are various flavors and implementations of this language. Okay, so there is not just one. The SQL language is kind of a standard that's there and is revised every few years, but there are different implementations of the same language. Okay, so it's just like, for example, you have linear algebra, but then you have different implementations of that in terms of NumPy, or for example in MATLAB, or in other packages in different languages. Okay, so linear algebra does not belong to C or does not belong to NumPy, but there are different implementations of that. It's the same thing here. SQL language, there are different flavors of that. Okay, so we have things like Oracle SQL, MySQL, which you might have heard of, PostgreSQL, DB2, SQL Server, Access, SQLite. All of these flavors exist in the market. This is important to know because, for example, like in previous years, we have seen people looking up ways to write a particular query, and they're referring to answers that, for example, is written for MySQL or is written for a Microsoft SQL Server. You have to know what database, what implementation of SQL we're working with, and the implementation that we're interested in is called PostgreSQL. So, what is PostgreSQL? It is an open source DBMS that basically just implements the relational model, and along with that, it also implements its own flavor of SQL. And the thing about that, probably most important thing is that it's free. So you don't have to pay anything, and it's very, very widely used in the industry. And this DBMS appeared in the 1980s in UC Berkeley, and then it was first called a language called Ingress, and then they kind of revised that, and they called it Post-Ingress, and then for short they called it Postgres. This is why it's called Postgres, just a little bit of history. Okay, so to recap, the implementation that we're interested in here is PostgreSQL. There are these other various types of implementations that we will not discuss in this course, but just know that those other DBMSs are very, very similar in terms of their functionality and the way that they implement SQL. There are just tiny differences here and there for what we're concerned about. Okay. Questions? Okay. All right, before moving on to actually writing some SQL and running those queries, I just want to quickly talk about the client-server model. Okay, so typical programs, when we run typical programs on our computer, there's usually just a program, and the program directly talks to the operating system, and that's the way it runs. For example, when we run Python, there is no server, client, or anything. You just run Python on your computer, and it just talks to your operating system and executes those commands. So it's not possible directly to have Python on another system and then run Python there. So basically, you have to use a network to log on that computer, and then from that computer run Python. However, you've seen that one of the main ideas about having a DBMS is for example, several different people connecting to the same database at the same time. So that's one of the main ideas. The other idea is that we basically want to move the computations from our own computers to the server. We don't want to do those computations on our own computer because we want to have a powerful server somewhere that stores like this gigantic amounts of data, and we want those operations to be done on that server, not on our own computers. This is part of the whole idea about having a DBMS. With Pandas, you have to do everything on your own computer. But with a DBMS, it just handles that for you somewhere else. You talk to the DBMS, and it sends you the data that you need. You don't need to store the whole thing on your own computer. You don't need to process the whole thing on your own computer. And this is an idea that has existed in the world of databases for long. However, it's just for the past few days, for the past few years that we've been hearing about cloud computing and cloud services, that we are no longer running things on our own computers and machines. We do all that stuff on the cloud. Okay, so this is the reason that all of these DBMS systems, most of them, are implemented based on a client-server model, meaning that the program runs a server, meaning that it responds to requests, and there are clients. For example, I can be a client. A program on my computer can be a client. We send requests to that database, and it sends response to us. So it naturally works over a network. This is why for database management systems, we always have to set up like an IP address, a port, usernames, passwords. It kind of works in that same way that we are used to connect to networks. So just wanted for you to have the idea why we're talking about ports and IP addresses when we're setting up a database management system. Okay. All right, so as soon as you set up, for example, the Postgres DBMS on your own computer, it fires up a server, and then now that server, other people elsewhere can connect to it. Your programs can connect to it. And it handles all of that automatically for you, okay? It takes care of like not letting everybody see the same kind of data. It handles giving different accesses to different people, setting up usernames, passwords, and also managing simultaneous access, all that kind of thing. And you can take the same Postgres installation, put it on a server, and then that could be the backend of a website. You just have that website there, you make your application send requests to that database, and there we go. We have a cloud computing service, and then we can do all the computations there over a network. Okay, any questions about this? Okay. All right, so now let's get to the more interesting stuff. How can we run SQL in Postgres? So when you started NDS, you went through some installation instructions. And as a part of that, you should have installed Postgres SQL on your systems. And the most important thing there was that there was a password that you had to set, and I hope that you remember that password. because we have emphasized that point, because last year we had a lot of problems, people forgetting that password. You have to uninstall things, and uninstalling Postgres is a little bit tricky. Okay, so yeah, there we go. A lot of lab time. Okay, no problem. This is how we learn. Okay, so if you have that, hopefully have that Postgres installation on your system, there are various ways that you can use your DBMS. The first way is to use pgadmin, which is the official GUI for interacting with Postgres databases. And just to give you a peek into pgadmin, this is what it looks like. Let me put it here. All right. So you will have a window like that, hopefully. And then you have your databases on the left-hand side. We're going to be talking about how you can basically use this GUI in more detail. But this is what it looks like. Okay. All right. So right now, you probably don't have this IMDb and World databases in your local installation, but I have posted instructions here in the lectures folder for setting up your own local databases. So you can read through that, but I will also go through that in the lab. This is just a couple of steps, takes 5 minutes, but just for you to set up your local database. Okay, so this is why you probably don't see this IMDb and World if you haven't set that up earlier. Okay. Okay, so just to show you how we usually use this pgadmin, I'm going to quickly run a query here for you. If you click, for example, this button here, it says query tool, and then here I can write select, and let me just make it simple here. I will tell you the meaning of this asterisk here, from country, and then if we do that, you get back all of the values inside of this country table in that database. Okay, so this is not for you to learn the SQL query right here. It's just to show you how the GUI works. Okay, so you have a query tool. You can use this play button in order to run your query, and then this is how it's used. Okay, there's another way of interacting with Postgres DBMS, and that's by using pSQL, which is the command line interface in order to talk to the database, okay? And we can access pSQL in various ways. If you're running Mac or Linux, pSQL should be available to you in your terminal. So if you just type pSQL and then give it a username, it should work. But if you don't have that, no problem. You can go to the installation folder of your Postgres, and there should be a terminal-like icon there saying pSQL or something similar, or CLI or something like that, right? Okay, so you can open that and use that. That's your PC, that's your CLI or command line interface. Yes? I can't hear you. Wait. Sorry. Yeah. Yeah. Yes. Yeah, so good question. So again, this is something that I will be going over in the lab. I have provided the instructions here as well as the database files. We call these dump files. These contain actually the actual data in the data set. And you have the instructions to populate your databases, your local databases, with these files. The instructions are there. But you don't need to be too concerned about that because we're going to be covering that in the lab. Okay, so I have to go a bit more quickly here, just to show you pSQL. If you want to access pSQL from pgadmin, you can do that as well. Here, if you click this icon, it says pSQL tool. And this is another interface where you can use it to run SQL commands. So select star from country. And yeah, so it's a bit messed up the way that it shows, but basically it works in the same way. Okay. All right. The other way that we can connect, so we can see that there are various ways to connect to the database, not just one single way. The other way that we use in this course a lot is by using these %SQL or $%SQL magic commands in Jupyter Notebook, meaning that we can connect to the database and send queries right from the Jupyter Notebook, and it's very convenient. The other way is to use this Python package psycopg2, which is the official Python package for Postgres databases. Again, something that we discuss in the lab. And also we have methods to query the database using pandas. All right, so I showed you pgadmin, I showed you pSQL. I'm going to show you a couple of commands that are useful in pSQL. So pSQL, again, is the command line interface for Postgres. And there are a couple of interesting meta commands to see what's going on in your database. For example, if I do /l, I will see a list of databases that I have on my system right now. So you can see IMDb here, you can see the world database here, and you can see the owner of those databases, which is a particular user. Okay, so that you can quickly do that, /l, and that shows you the list of databases available. And if you're connected to a particular database, like the world database here, you can also quickly type DT, and that shows you the tables inside of that database. So here you have the city table, the country language table. Okay, so /DT. All right. And if you want to connect to another database in that server, you can do /C followed by the name of the database, and then it now says you are connected to database IMDb as this user. And now if you run DT again, you see a different list of tables. So these are just a few quick commands in order for you to inspect the database and the server that you're on. Let's kind of see the tables that you have. This is kind of the first few questions of the lab. And you can achieve that easily by using pSQL. You can do that using the GUI. You can see a list of tables and everything here as well, but it's going to take you quite a few clicks and looking for stuff. So this is the preferred way. And you don't need to memorize these commands. There are just a handful of those that are useful to us, and you can just refer to this table over here. An important point here is that remember that these are not SQL commands. These are pSQL commands. Okay, SQL language is a totally different thing. Okay? All right. Now, let me also show you this IPython SQL thing. So if you have created your DSCI 513 environment, you should have installed IPython SQL as well. So we can load this extension like this. And then once we do that, okay, so before that, here's the part that we have a credentials file that we store our password and username inside of that. And again, because this is a database server, we need to have a server address, like an IP. We need to have a port, a username, and a password. And instead of directly putting that into our notebook file, we put them in a file, and then we add it to gitignore so that we don't commit it to GitHub. That's very, very bad practice to directly put your password and username and everything else inside of your notebook. So I'm going to run this, but I will discuss this more in detail in the lab. The most important thing is this connection string. So you can see that %SQL. And then this is the syntax that we should use to connect to a particular database inside of this, on this host, on this port with this username and password. So you can see that I haven't inserted my password and username directly here. I've put it in a file called credentials.json, and then I'm reading that file, and I'm not committing that file to the GitHub repo. Okay, run that. It says connected. Okay, now let's give it a try. So select name and population columns from the country table. All right, it works nicely. Okay, without having to go to pgadmin and do a bunch of jumping through hoops to run things. This is very convenient for Jupyter Notebooks. Okay, so note this magic command over here. All right, so this returns everything inside of that table, which might not be something that we want. So there is this config command that you can use to limit the number of rows that are shown by default in the output. So now if you run this and then run this again, it only shows 20 rows out of the 239 rows. Okay? So I usually put that at the top cell in the labs and in the lecture notebooks so that you don't have a bunch of rows being outputted to the screen. Okay. And then the most common way that we use to run SQL queries is by using the double %SQL magic. It just turns the whole cell into a SQL cell, basically, and then you can just conveniently type whatever command you like inside of that cell. All right, so works fine. Notice this semicolon here, and the from clause, the select clause. Okay. And the thing that I did in pgadmin, I did select star from country. Star means just retrieve all of the columns in the database, in the table for me. And if we do that, okay, yeah, it took a little bit of time. And now you can see all of the columns are retrieved from that table. Okay. And this part is really not necessary. And we're going to discuss a few basic SQL commands after this. But before this, let's see if there are any questions. Yes.
Giving a query to SQL in a Jupyter notebook, it returns a table. Is there any way we can then kind of read what pandas or?
Yeah, great question, great question. Yes, that's exactly right. So what is returned to you is actually not it looks like a pandas data frame, but it's not. It's a particular object pertaining to that IPython SQL package. But in the section that I skipped, which is not that important, I discuss how you can turn that into a pandas data frame as well. Wait, sorry for the scrolling. We have that here, and then have that here. Okay. Okay, so yeah, when you have a query output like this, you can save it inside of a variable like that, okay? If you do that, then this is something that you see on the screen, but if you inspect the type, it says SQL.run results set, so it's not a pandas data frame, but there is this .data frame method that you can use to convert this thing into a pandas data frame, and right now this is the good old pandas data frame that we were used to. But usually we don't do this. If we want to return things in pandas, there is a pandas method called read SQL query where we can directly write SQL query as an argument and run that. There is another way using the scipg2 package. I will discuss that in the lab. Yeah. But great question, because we need to have an interface in order to get that data into our Python runtime in order to do further processing. Okay, so a few more SQL commands before we end this lecture. A few basic ones. So there is this keyword that we can use called distinct. And what it does is that it's just is applied to all of the columns that we list here, and it returns all distinct combinations of those columns to us. So if you have several rows that contain the same values for column 1 and column 2, it just returns one of them. It's usually useful for when you want to count stuff that are distinct in your table. So that's one useful keyword. Here we have an example of that. If I get rid of this distinct, you will have a lot of repetitions, right? You have Africa, Africa, Asia, Asia, North America, North America. So you have 239 rows. But as soon as I put distinct there, we expect to see only just these 7 continents. So that's basically what distinct does. Okay, so that was distinct. And if we do that on two columns, it basically applies the same thing onto two columns. It looks for distinct values in both of the two columns. Okay. So remember that we cannot selectively apply distinct to one column. This doesn't mean that retrieve distinct values for continent, but not region. It applies to both. Okay, that was one thing. This is optional. This is a Postgres thing, not SQL. And then we have an important keyword here, ordered by, or important clause, which helps us basically sort the outputs of our query. So if you remember, I told you that there is no order between the rows stored in a database, but stored in a table inside of a database. There is no inherent order, okay? So if we want to sort the results that are returned to us, we can use this order by, and you can order by one column or several columns. So for example, here we have select, we retrieve the name and population columns, and then we choose that from the country table and ordered by population. If I do that, the first rows that appear belong to places that don't have any population recorded for them or have very small population. But with order by, I can also use this keyword ascending or descending, as you can see here. It by default orders in ascending order. However, we can add descending, DESC, and if we do that, it sorts the data in the reverse order. So now you can see the most populated ones appearing at the top. And this database is outdated, so if you see a lot of results that don't really make too much sense right now, it's because it's quite old. Okay, so this was order by, and again, another simple clause is the limit clause. So if you don't want all of the rows to be returned to you inside of a table, so for example, you can have 5 million rows in a table. You don't want to return all of them just to quickly inspect what your data looks like. In that case, you can use that limit and do, for example, limit 5, limit 10, something like that. So here, I do limit 5, and then it returns only 5 rows to me. It's very helpful to quickly check out your tables in order to see what's going on, what kind of columns you have, what kinds of data you have. Okay, that was limit. It can also set an offset, not really important, something optional here. And last thing that I just wanted to allude to but not go into the details of is that the order of those SQL clauses does matter. We cannot put the from in the beginning, we cannot put the where after order by, and there is a reason for that, which I'm going to be discussing in the next lecture. All right, so any questions? We have 3 to 4 minutes. Yes? Pardon me?
How can we open a new database in PGAdmin?
Oh, okay. So how can we open a new database in PGAdmin? This is something that I have mentioned in the instructions here. So if you open up this file, it's explained here. But basically what you can do is that right-click here, create a database, and then you give it a name and click Save, and then you will have an empty database. And then if you have the dump files just like I have here, you can just reload all of that data and all of that information about schema and everything into that database. Yeah. Questions? Maybe 2 questions. We have time for 2 more questions. Anything about these clauses, limit, order by? Yes?
For example, when you apply an order by, you said that the management system takes care of the processing.
Right.
Since we learned that there are better ways of ordering things,
Mm-hmm.
does it have an impact on that when you're talking about very big databases?
Okay, great question here. So, okay, we have learned in 5.12 that if the data is sorted, the data that we have is sorted, then retrieving particular data from that table or that data set would be much easier, much faster. However, if it's not sorted, then it will be much slower because we have to do linear search. Does that affect the way that we retrieve data from our database? The answer is yes. So when we do this order by, the database has to go through sorting the database, basically using those sorting algorithms, O and log n, something like that, in one of the sorting algorithms. But there are ways to pre-index the values in the data set in the table so that particular operation takes much less time. So we will discuss that in lecture 6, I guess. Yeah, but great question. All right, thank you, everyone. That was it for today's lecture. I'll see you in the lab tomorrow.